In today's lesson, we are looking at end behavior of functions and then extreme values of functions. And first, we're going to look at end behavior relating to horizontal asymptotes. So the first function, x over x to the third plus 1. So what do we know about the horizontal asymptote of this function? The degree is higher in the denominator, so we have a horizontal asymptote at y equals 0. So you don't need to sketch the graph, but I'm just kind of showing you what this graph does look like. So what we're going to do is describe the end behavior. That means what is happening as our x values go towards the end, as our x values approach infinity or approach negative infinity. So how we're going to write this is we're going to write as x approaches infinity, what is the y approaching? As you are approaching infinity, the y values are approaching that asymptote at 0. And then what's happening at negative infinity? Y is also approaching 0. It's approaching 0 from the other side, but it's still approaching 0. This right here is how we are describing end behavior of functions. So here's our next function. To understand end behavior, it's helpful to look, is there a horizontal asymptote? And what is it, if so? So in this case, there is a horizontal asymptote. We have the same degree top and bottom, so it's the coefficients. And again, here's just a quick sketch of the graph. You don't need to graph that, but just to give you that visual, as x is approaching infinity, y is approaching that asymptote. As x approaches negative infinity, it's still approaching the asymptote from the other side, but still approaching the same number. So as x approaches infinity, y is approaching 2/3, and as x is approaching negative infinity, y is approaching 2/3. And now here is a third example. In this case, what do you notice about the exponents? We have a higher degree in the numerator. That means that there is no horizontal asymptote. So how can we describe end behavior? So here's what this graph looks like. There's no horizontal asymptote. So as x is approaching infinity, notice how y is shooting up towards infinity, which makes sense when the numerator, if you were to plug in infinity, the numerator is going to grow much larger. So it doesn't go down to an asymptote, it goes up to infinity. But now what happens when we're going towards negative infinity? It's shooting down. And that makes sense because if you plug in negative infinity, this exponent would make it go positive, but then this would be negative, and a positive and a negative would make it negative infinity. So in this case, as x approaches infinity, y is approaching infinity. And then as x is approaching negative infinity, y is approaching negative infinity. So here's just a little intro on how we are describing end behavior of functions. Okay, so now I'm not giving you the equations. I'm just going to give you 3 graphs. I want you to sketch them. I want you to pause the video and see if you can describe the end behavior. So here are the 3 graphs. Sketch them quickly on your notes and then pause the video and see if you can describe the end behavior. So let's see, the first one, as we're approaching infinity, the y values are approaching infinity. As you're approaching negative infinity, the y values are also approaching negative infinity. Okay, for this one, as we're approaching positive infinity, the y values are approaching 0. But as we're approaching negative infinity, the y values are approaching positive infinity. And this last one, as x values are approaching infinity, y values are approaching this asymptote at 3. And negative infinity, they are also approaching that same asymptote at 3. just from the other side. Now I'm going to talk briefly about polynomials. We talked a little bit about this in Algebra 2, and our next unit in pre-calc is actually polynomials, so we'll come back to this topic. But the end behavior has a pattern when you have the highest degree as an odd exponent versus your highest degree as an even exponent. So with an odd degree, your graph, it can do lots of different things, but it has this end behavior. It might do all kinds of stuff in the middle, but as you're approaching infinity, it's going up. As you're approaching negative infinity, it's going down. Now this is when you have a positive leading coefficient. So I'm just going to write LC. When you have a negative leading coefficient, it's going to flip. So in this scenario, odd positive leading coefficient, as you approach infinity, y is also going to approach infinity. And when you approach negative infinity, y will also approach negative infinity. But then when the leading coefficient is negative, it switches. So as we're approaching positive infinity, y is approaching negative infinity. And as x is approaching negative infinity, y is approaching positive infinity. Okay, and then if you have an even degree, the behavior will do something like this. The middle could do something crazy like that. But the idea is as you're approaching positive, positive, approaching negative, also positive. They're going the same direction. And this is with a positive leading coefficient. And when you have a negative leading coefficient, it could be like a parabola. They're both pointing the same way, but they're flipped. So for this first example, approaching infinity, y is also approaching infinity. Negative infinity, it's still positive infinity. These will always be the same. So in the last example here, y will approach negative infinity, y will approach negative infinity. So these will be the same. So once again, polynomial end behavior, talking about it now, but we will spend more time on it in Unit 2. Okay, now we're switching gears a little bit. We're not looking at end behavior, but we're looking at certain special points on a graph. And it's your relative and absolute extrema. They're also referred to as points of inflection. So we're going to do a few things, all referring back to this function. Negative x to the fourth plus 5x squared plus 2x. So here I did just a quick sketch of that function. I don't need to be super exact right now, but do your best to make it look good. So the idea of extrema would be like the highest or lowest point. If you want the full definition, an absolute extrema would be the greatest or least value over the entire domain. So if you look at this graph, this right here is the top point. That is called an absolute maximum point. And because these go down forever, there is no absolute minimum. But now, what is going on here? It's reaching a maximum, coming back down. It's wherever we're changing directions, that is your relative extrema. So that definition, it's the greatest or least value within a certain interval. Now, I'm going to show you how to find those exact points, the relative extrema and absolute extrema, on your graphing calculator. So just watch for now. We'll spend time going over it in class, but I put in my function in my y equals. Zoom 6, I'm just getting that standard window, and I'm graphing it. Now you can calculate that second trace, and now see minimum, maximum. I'm going to do maximum and go to my max. But notice how it says left bound. Pick a spot left of the max and hit enter. Right bound, pick a point right of it, hit enter, and then you have to enter one more time, and then right there you get your maximum value, your absolute max. So now you can do that same process to find your relative extrema. This is still a maximum, and then you go in and you find a minimum. So that's using second trace. And you can find those, you just have to do left bound, right bound, and then guess. So I'm going to give you those values, the relative max and the relative min. But maybe pause the video and try it on your own quick and see if you can get the same numbers that I got. But the relative max, this point right there, you should get negative 1.47, 3.20. And the relative min right there, you should get negative 0.20 and negative, 0.20, same x and y value. So I know that's a lot of information, but there's your full video on describing end behavior of functions and then finding those points of inflection, relative and absolute extrema. Good luck with your lesson.